Mostly you live in the upstairs in the light, but the basement is needed, but it's also, you mostly ignore it, and it's mostly dark. And if you are interested in foundations, you go down there with a torch.
Hi, Jeremy.
Hi there.
So, this is the start of a series of meetings and chats about the foundations of physics. And let me say that I'm, first of all, extremely happy and grateful to start the series by talking with Jeremy Butterfield. Do you mind, Jeremy, if I say a couple of words just to introduce you, and then we start our chat?
Okay.
So Jeremy Butterfield is a very highly respected and influential philosopher of physics, and particularly interested in foundational questions of physical theories, foundational aspects of physical theories. And this is basically, and he works at the University of Cambridge, and where he has been for many years, having been before in Oxford, and similarly respected and influential when he was in Oxford. And beyond that, maybe the only thing that I need to say is that Jeremy has been nominated for a number of informal prizes and awards having to do with being the nicest person on earth. And I'm not sure that never became a formal competition, so I don't think he can have any trophy at home confirming that, but that's one more reason to be happy to talk to you, Jeremy.
Well, what a completely, as we say in England, over the top introduction. Very, very sweet nature of you, Daniele, as I know you are. But we'll try to, we shouldn't linger on this topic, but I will try to be nice for the interview at least.
Okay, very good. So, well, you know, I cannot resist but adding that the more you say that, the nicest you sound. So actually it's a sort of self-contradicting posture. Anyway, very good. So I'm happy, you're happy, I hope. So let's start talking.
Sure.
So maybe the first thing that I would like to talk to you that could be of interest for everybody who's listening is why is it that we are talking to each other? And to put it maybe in a nicer form, why is it that, you know, a theoretical physicist is or should be talking to a philosopher, and why more generally they both should be interested in the foundations of physics?
Right. Yeah, so this is a lovely question. So I myself was trained originally in philosophy, very much analytic philosophy, like Bertrand Russell and Ludwig Wittgenstein. But I got keen on physics. And after some years, after the PhD, really devoted myself to what we call philosophy of physics, which is this small community at the interface between physics and philosophy, which grew really from 1990 and is now a happy band, which is in good contact with theoretical physicists like you, thanks, I think, to the intellectual generosity and welcome of the theoretical physics community. But looking back over much longer time scale, I think I would say that, and this will be music to your ears and people in either the physics community who talk to philosophers or the philosophy of physics community, it's worth saying, but it's not a surprising claim. If you go back to Aristotle or Newton or Leibniz, you find conceptual discussion of concepts like space and time and matter and causation. And these conceptual discussions are in words, not in mathematical formulae. And they look like philosophy on the page. They are words, abstract, conceptual, not about a specific physical situation, like let us calculate what is the velocity that a rocket must have to escape from the Earth. They're about the more general features of space and time and matter and causation. And as you will know, I mean, in the 17th century, when physics in the tradition of Galileo and Newton got going with mathematical descriptions of nature, which were quantitative and numerical, in those days, the topic was called natural philosophy. It wasn't called physics. Natural philosophy, also called the philosophy of nature, just meant human inquiry into how nature works, right? Because philosophy in those days, from the Greek philo, like, or loves, sophia, wisdom, meant love of wisdom. And so philosophy of nature, or natural philosophy, meant inquiry into nature, partly by experiment, of course, crucial, partly by trying to be, careful and systematic in your thinking. And the sort of training or the temperament that leads to a philosopher, not an experimental physicist, is a temperament or a training that tries to be careful about thinking. So if we have anything to contribute, we philosophers, it would be, obviously, we are ignorant of much detail in physics, and we shouldn't be trusted to calculate anything, even if we've studied the theory in question. We'd be much less quick and reliable in detailed calculation, but we might have a good perspective on the shape of the reasoning, or the two concepts got mixed up in this discussion. And in fact, if we think that there are two concepts, if we keep them apart, maybe we get a better understanding. This is the kind of contribution.
Can I add something? So you're basically saying that I, as a physicist, that I'm involved in some complicated calculation, or I'm trying to grasp some complicated conceptual issue within my own pet theory or beloved framework, I should knock at your door and you will help me clarifying the fog, so to speak, or making sure at least I'm being consistent in my reasoning, in my own thinking about the given issue. And that is supposed to then feedback on my own ability to do the calculation or hit on the right question, and this type of role.
Yeah. Yes. I mean, that is sort of implicit in what I said, and I have to admit that this was perhaps a bit ambitious and a bit self-serving description, because actually, I also believe that almost all the time, you physicists are very conceptually clear-headed and not in a fog, which philosophers are needed to we have some, friendly neighbor role, but it is, I think, true that much of the time research in fundamental physics is, the conceptual aspects are well understood by the practitioner. At least as well understood as even the best philosopher.
Can I make just two comments here? One is to some extent confirm and say that then after what you said, that the role seems to be more like, the good friend to whom you go and talk whenever you have a problem. And okay, you are the one who actually knows what's wrong and what the issue is and what the details of your problem are. But just to get a fresh alternative perspective from somebody who can see things a little bit from a different angle can help you clarifying, even if you do the clarifying work on your own, but still you get an important input from your friend.
Yes, I mean, I'd like to say that. Yeah, I hope we can be like that. There is another role to the philosopher of physics, of course, which we didn't say yet, and that is to carry into philosophy the insights of science. And so far we talked about what in answer to the initial question, why are you and I in different departments able and interested to talk, or why do our communities talk to one another? We talked in effect about the role towards physics or scientific inquiry. But yes, the philosophy is a humanities subject, and it is a big picture subject that tries to present to the educated public interested in general issues a picture of the world. And of course that will mean political philosophy, moral philosophy, aesthetics, but it should also of course include the scientific world picture in broad terms. And so making philosophy out of the details of science, that's certainly a role for philosophy of physics.
Okay, but then let me add two things as well, just to complement. So one is an impartial contradiction to what we said earlier. You said that most physicists, or at least physicists in general, are capable of clarifying their conceptual aspects on their own. And yeah, that's very nice of you, but my own experience as a physicist, not only just as my own work, and sometimes personally I do feel that I need help to clarifying the conceptual aspects of the problem I'm trying to solve. But even more generally, very often I have the impression that that's indeed something that physicists are not used to. A good part of the physicists I know, I mean, with all due respect, I have many friends who are physicists, they see their task as indeed to solve some particular technical issue within a framework, and they never, or very rarely, or let me put it like that, not often and not constantly, they question the framework, conceptual as well as technical. And very often they don't question exactly what is the goal of their own calculation beyond the technical point. So what is that they're trying to understand? What is the general meaning or the impact at the broader level of what they're trying to do? And this ties to the other thing you said. So on the one hand, if this is the situation, what I see from experience very often, then to me, at least, it's quite clear that philosophers are actually important to force us to take the extra step and ask some more questions about our own work. And then the other thing you said that struck me very much, because the reason why I went into theoretical physics, and that's a personal confession on record, was that in fact I was interested in the philosophical questions. And then for a number of reasons, right or wrong, I decided that the best way to answer those questions was to do theoretical physics. But to me, it was clear that whatever I was doing as a physicist was meant to answer, or at least to contribute to answer, those bigger conceptual philosophical issues. Does that resonate with you as well?
It does very much. I mean, partly it reflects your own creativity and your intellectual personality about the kind of physics you have done and are doing.
Yeah,
But
sorry, this will be edited out.
no, I hope not. But I think that there is a more general point, which I had a little bit in the back of my mind when I was talking about the role of philosophy and physics is partly to carry the insights of modern science, in particular physics, into the wider culture. And it is a bit of a sad fact about the history of philosophy in the last 200 years that people like you who enter physics in order to better understand nature are sometimes, saying, I'll go into physics, because although I had philosophical interests, I am finding that philosophy is all about logic or mind, and I'm more interested in nature. And there is a story there about what happened to philosophy between 1750 and 1950, which made it more separate from physics, or indeed from empirical science in general. And it's worth perhaps saying out loud, this is in a contentious way, there it was, natural philosophy in 1700, in the time of, say, Newton, and with the great Swiss genius Euler right through to the 1750 and later. But then two big things happened. One in physics, one in philosophy. Physics got more technical, and so you couldn't really do moral philosophy and political philosophy and so on with depth and coverage, while also really following Euler's fluid mechanics, because Euler's fluid mechanics was a full-time occupation, right, in 1770. Or Lagrange, or these other geniuses of 18th century physics and mathematics. So this specialization in physics led to physics and philosophy separating a bit. And the other big event was in philosophy, and that is that Kant came along in philosophy and began a tradition called transcendental idealism, which deliberately did not want to talk about the details.
Mm-hmm.
It was big picture, very, very big picture thinking. Even the most ardent advocate of Kant would agree to my description that it was very big picture thinking, and it didn't engage in the detailed contemporary science. Kant himself did try to engage in the detailed contemporary science, but the legacy or tradition or the influence with people like Fichte and Hegel and 19th century German philosophy was not very, whether it was Hegel and his legacy or Kant and his legacy, it was not detailed engagement with the deliverances of science. And the other thing that happened was that logic came along in the late 19th century under German genius Frege, and with followers in Britain like Russell.
Mm-hmm.
And this, I always like to joke that it's like the child with the new toy, very excited by the new toy. Philosophers leapt on mathematical logic as a set of ideas and methods with which they could attack philosophy problems anew. And this led to great things in logic, and you might say in philosophy, the so-called analytic philosophy tradition. But Russell and the others did not engage adequately with the ever greater conceptual interest of physics after the late 19th century. And, from the late 19th century, Maxwell onwards, we have quantum coming and relativity, and we have the thermal physics of Boltzmann and Gibbs, and all those enormous changes in physics hardly registered in analytic philosophy until 1980 onwards, really.
It's interesting if I can creep in that you trace back this separation between physics and philosophy in the late 18th and then 19th century, because I always thought that if I had to identify the culprit, I mean the historical culprit in the separation is actually the post Second War period, with the moment science itself became not only even more specialized, but highly industrial, like organized in a production machine with the big projects and large communities and very high level of specialization. And I always thought that it was from that point onwards that physics and philosophy split. But you're saying that in fact the root of that split was in fact much older. And that's the reason why even quantum mechanics and relativity that was pre-Second World War didn't really catch on to the philosophy community.
Yes, I mean, I think this is my reading of it. But as I said it, I did also have in mind, qualifications. As somebody once joked, first you say it and then you take it back, right? I mean, in two ways. One is it has to be admitted that in the German tradition in the 19th century, natural philosophy did exist. There was not just Kant and Hegel and their followers. There were people like not a name not very much known, Brentano, and in Vienna, people like Boltzmann were writing what we would now call philosophy of physics essays, and Ernst Mach, M-A-C-H, the speed of sound. These great Austrians undoubtedly were writing essays that would count as philosophy of physics now, or natural philosophy. And in Britain, Maxwell also wrote, as did other geniuses, in words, not always equations, and they were not always just solving a specific physical problem or elaborating a general theory that involved exactly equations. They were talking about space-time, matter, causation in general. So there was certainly that, but it wasn't, so to speak, center stage amongst philosophers as a whole community. It was being done by physicists or all-round polymaths like Ernst Mach. It was not being done by people who were professionally philosophy. I also have to concede, in another way of taking back, relativity, of course. Einstein's relativity did have an impact on German philosophy, and via the schools in Berlin and Vienna, it had an impact on English-speaking philosophy. But the quantum, sadly, did not, really.
So let me stay for a second at this general level, and then we start talking about specific issues in the foundations, if you're okay with that. So general, sure. I want to ask your opinion about. So one could think that foundations of physics, if it has a relevance, and we hope that we have convinced people who are listening that we are reconnecting to a long tradition. We are not really coming up out of the blue with a new idea about what philosophers can tell physicists and vice versa. I mean, philosophical reflection on the foundations of physics, as we said, has a long history, and we can say that there was just an interruption of a dialogue and that that is starting again. But one could still maintain that it may be some fancy area of physics, frontier science or speculative corners of science that may be in touch with philosophy and foundations. But then, if I go to a Foundations of Physics conference, there is foundations of thermodynamics, foundation of statistical mechanics, particle physics, areas of physics that one would consider established. Yes. So is it a different role that philosophers play in those areas as opposed to more speculative frontier, unsettled areas?
Well, I get what I feel is that the role, the skill set of the philosophers is about the same, though. So what we can contribute takes the same quality. But you're absolutely right that the philosophers / the foundations of physics folks are often scrutinizing an established theory. And this, as we say in England, whether you have advantages and disadvantages of a given enterprise, or, you have features that are very different from one another, we say that it's a matter of swings and roundabouts. Because when you take your child to the fun fair, they can go around and around in a circle, or they can swing like a pendulum. And so swings and roundabouts means diverse activities. And, for fundamental physics of the type you yourself do, and which your, research focus is at Munich is clearly addressed to, then it's more like we said at 20 minutes ago, the physicists may feel there's a fog, and maybe the good friend, the friendly neighbor philosopher talking to them helps. But it is true that because this is not yet finished physics research, the philosopher's contribution is going to be more guesswork than it would be if you asked the philosopher to please do an axiomatic study of thermodynamics. But because I say axiomatic study, because that, of course, is the kind of phrase that comes to mind to us philosophers when we talk about something like foundations of a physical theory, because we come from a logic training, thanks to Mr. Frege and Mr. Bertrand Russell and our undergraduate years. And so we understand the idea of an axiom system as, a small set of crucially central propositions from which you deduce the entire body of doctrine that you call your theory. And it is enlightening to axiomatize a theory that you know and perhaps even love, right? By axiomatizing it one way, you will see some things as central, and you might want to axiomatize it a different way and see other things as central, and you'll certainly increase your understanding of this body of doctrine in such an endeavor, but it won't really be guesswork, and it probably wouldn't help the research physicist unless it just so happened that the research physicist, this would be unusual, that their research problem depended upon something that was caught by or articulated by the endeavor to axiomatize. Anyway, this is my kind of example. It's a swings and roundabouts.
Can I make an analogy? Let's see if I understood your point. And so the philosopher for the physicist is the friend with the torch that can do two things with that. Either it comes with you in the basement and where initially you don't even find back the light, you turn it on, then it helps you tidying up, and occasionally helps you finding some items that was lost. And that's the case in which it's working with you on established areas of physics. But the same friend can actually come with you in some, in some path during the night, exploring some new territory, And occasionally it points the torch to the right, in the right direction, and it helps you actually finding the way. Even it's you who is driving the chart with the horse and whatever, however you're actually going through the path. And
yes,
is that the difference?
I'm sure that is the difference.
So it's the same tool, but it can be used in different ways. And
yes, and the basement, of course, is good because it's the foundations.
Sure.
And the building depends on it. But it's true that mostly you live in the upstairs in the light, and you have your life and you do your practical affairs. But the basement is needed, but it's also, you mostly ignore it, and it's mostly dark. And if you are interested in foundations, you go down there with a torch. But yes, it's true that the physics community has more torches or knows where the light switch is and can probably illuminate the basement at least as well as the philosopher friend who has a torch.
Yeah, but then occasionally we need to call the philosopher friend because we are actually going to explore at night a totally new area of the house or the neighborhood, the forest even. And then with the same tool, we actually try to do something new. And so let me go in that direction.
Yeah, I love your analogy. I think you should write an article.
Well, okay. But then, okay, if you like my analogy, then this is my secret weapon, because before we move to some specific topic, I want to quote you, but from my memory, so you don't have to subscribe to what I'm going to say. I take full responsibility for the statements. At some conference that I attended, and you were one of the speakers, you try to stress why, in your view, philosophers should learn and be brave enough to work together with the physicists on frontier, unsettled material, even though, it's risky, because whatever they say is based on some partial understanding of the theory that tomorrow can turn out to be wrong. And you, as the sort of the counterpart of this risky business, you mentioned 3 ways in which philosophers can actually do philosophy of physics. And it was clear that you were quite critical of those 3 ways. So let's see if I remember them. So one was the Greek choros, the philosophers that just come after the fact, after the physicists have done with their theory, with all their action, the things have happened already. And they start prizing, how good were the physicists, how clever is the thing that was done at some point, how terrible is the mistake that was done at some other point, but not really contributing to any of the action, any part, even a small part of the drama. I mean, they arrive afterwards. The other role was what the pilot fish.
Yes.
The one that lives in symbiosis with the white shark, and its content was simply cleaning up the teeth by removing a little bit of remnants from the meal. But again, it doesn't really give any big contribution to the life of the shark, of the whole biological fight that happened right before, or the survival of the shark, of any of the other fishes that tries to escape the shark. It's to some extent is useful, but also kind of irrelevant to the big picture. And then the third, again, was the scavenger, the animal that just preys on corpses of dead theorists, and explains again afterwards, happily, and makes a career out of explaining why a theory was in fact dead and wrong, and what was wrong with that. And do I remember correctly that these are?
Yes, I'm sure you do. I think I think it was in Chicago that we were there,
right?
Because and I think that the I must say the Greek chorus metaphor I simply stole from the wonderful physicist who we both know, Chris Isham, at Imperial College, now retired. And it was Chris who said to me, just off the top of his head, long ago, well, yes, it's a bit like the Greek chorus. They comment and on the action, and they summarize it afterwards. Yes. I think the pilot fish might have been my own idea, but I'm not sure. But certainly the Greek chorus I simply stole from Chris Isham. And, well, they're all three images that, have a certain truth about philosophy of physics.
Yeah, let me
relate into physics now. Yeah.
Let me reassure who is listening that Jeremy is known of the three types, and is in fact the friend who tries to help in finding new, new territories and understanding what's going on in parallel with the work of the physicists. And given that you mentioned Isham, that brings me to the next point. I have one more personal confession. When I was graduating my first degree, finishing it was master level, so finishing my master, and I was trying to decide what to do afterwards and what type of sub-area of theoretical physics was the one I wanted to waste my time on. Well, I came across one influence that I received, and very important, was from a paper by you and Isham on the emergence of time in quantum gravity. I think it was 1999.
Yes.
And so very belatedly, I thank you for that. Or I hold you responsible for everything that happened after, including the bad things.
Yeah.
Let me ask you to tell me your opinion, and to all the others, what do you think is the foundational importance of quantum gravity?
Well, yes. This, of course, is this is a fun question. It's a very deep and important question, but it's a fun question given that you're asking me, as if my answer might be worth it. Whereas, in fact, your answer would be much more worth it. But okay, you are asking me, so the natural answer, is the foundational importance of quantum gravity, rather than the philosophy importance. But quantum gravity is, of course, it's an umbrella term, as we say in English, meaning it covers many different endeavors, like a wide umbrella. And this covers the effort to reconcile Einstein's theory of gravity, general relativity, with quantum theory. And they are very different, though they could be brought together successfully, even with quantitative calculation, in certain scenarios, or what you would call in physics regimes. I mean, for certain energies or for certain distances or lengths, one has good general reasons to believe that one can apply this bit of quantum theory with this bit of general relativity and get reliable predictions out. But the background structures of the theories are they don't fit well together. So we all agree in modern physics, I think, that some reconciliation is needed, despite the fact that one can have limited success with limited applications of both. In limited way. So how to achieve this reconciliation is unknown. And it depends how you count, of course. You could say there are 6 main research programs about how to do it, or 20, or 3. And you are the leader of one such very profound program. And in that way, the philosophy or the foundations aspect, of course, is, well, we can hardly guess which is right because we're only foundations/philosophy. And in a way, nature will dictate which is successful. But we can, without knowing which is successful, we can at least assess what are the ingredient ideas of the different programs. And that is probably worthwhile even for somebody who is a committed advocate of one of the programs to sometimes stand back from the detail and compare their assumptions or motivations with what assumptions and motivations other programs have. But so this is not quite Greek chorus commenting afterwards. It's more like we're halfway through the tragedy or the drama. Let us be more positive. We're halfway through the drama, and the chorus or the philosopher comes on and says, at this stage, things could go 4 ways in the light of the following assumptions and motivations. And that has a certain, I mean, it spoils the suspense of the second half of the play. But this, I mean, of course, academic life is not about being exciting. It's about being sort of clear. And so being clear about what the options are, it would be.
Let me bring another perspective on the same question I asked. So I could mean by the same question. So what is the foundational importance of quantum gravity? Something also slightly different. So I meant what I said and what you answered about. But I now comes to mind another possible way of intending the question, which is suppose that we find it. We find the theory of quantum gravity. I mean, I don't know if that happens in next week or in a few months. It depends how much time I manage to work next week. But so whenever it comes, why the result will be of importance for philosophy or for big conceptual issues, even in physics, but at that conceptual level. And not just, okay, now we have a better theory for doing our calculations and predicting astrophysical phenomena or cosmological stuff. What would be the foundational impact of such a theory if we find it when we find it?
Yes, this is a lovely question too. What I'm inclined to think to say is very much a typical academic's answer, because we've got this English word intellectualism, which means the belief and the advocacy of matters of the intellect. And there's even a good colloquial word for a person who is very involved only in ideas, abstract, and they're called an egghead. It really means, so to speak, brainhead. It's not really to do with egg, but it's a bit died out now, but the word egghead means a person who only considers the most academic or theoretical or abstract or useless topics. And I think if we had this wonderful quantum gravity theory, part of it being wonderful would be that we would have a good understanding of how previous successes made sense. So when I was saying we do have these limited successes in so-called limited regimes, where the general relativity of the quantum theory can be both applied and get a good prediction or description, the idea would be that with the final successful theory, we would really understand how did we manage to make that successful localized combination. Mm-hmm. And, well, that would only really give an egghead satisfaction to better understand yesterday's successful localized application. But at this point, I just want to if you like, confess or proudly insist, right, that it is part of the human endeavor to understand nature. And, of course, there are more important things for most of us to devote ourselves to because there's so much trouble in the planet. But if it's worth publicly funding inquiry, then some of that public funding ought to go to things that it is clear from the tradition are fundamental. And so the egghead deserves some money.
I can say that the egghead, that word goes beyond my level of English. But anyway, the egghead in me found in your old paper exactly the sort of goals that I were exciting enough to start, with the whole career in that direction. I mean, and they coincide with foundational philosophical issues and exactly with those that you mentioned at the very beginning of our conversation when we were discussing what sort of questions ancient philosophers and, more modern but not contemporary philosophers were actually involved with. I mean, what is space and what is time and matter, and how should we really understand them? And, the extra question, and I cannot think of any more foundational question than what is space, what is matter, what is time, and in all their many facets, many aspects. So somehow you're totally right that you hit on those questions the very moment you accept not to stay limited to those limited regimes in which you don't really need to shake the pillars of our understanding of nature, and you can just patch together what we know already to some extent. And would you also see still after 23 years, you still see quantum gravity in the same vein, in the same look?
Yes, I think I do. Yeah. I mean, I hope that's a good thing.
Well, it would have been terrible if you were saying to me live and on record that, no, you misunderstood me.
No.
3 years ago, you misunderstood me badly.
No, I mean that, and well, I mean, going back to the maybe a little bit suspicious advocacy of the value of the quantum gravity research, right? It's a little bit suspicious because it's self-serving. I do think that the difficulty of making this reconciliation between general relativity and quantum theory is shown by how long it's taking to do, but that is absolutely not the reason to be disenchanted with it. And indeed, our dear colleague Carlo Rovelli, you and I both know, he has this wonderful analogy in his paper called Halfway Through the Woods from 20 years ago, where he says between Copernicus saying that the sun was at the center of the solar system and the planets rotated around it in the 1540s, and 1687, when Newton produces his masterpiece, this 150 years is a period of many-sided controversy and uncertainty. But the Newtonian synthesis then sets the stage for good progress. But if we go back to the middle of that period, like the time of Galileo and Kepler or Descartes, they were, as he puts it, halfway through the woods. They were struggling with genius to understand the phenomena And looking back, we see great falsehood and great truth mingling on their pages. Well, we are now halfway through the woods in the effort to reconcile general relativity. It's like you said, maybe next week or maybe only in 50 years. It's impossible to say now, but we must keep trying. Yeah.
Okay, so let me touch on another point. And you said correctly that there are many approaches, many candidate formalisms and directions towards a theory of quantum gravity. And you also correctly pointed out that depending on how you define them, somehow depending at which resolution scale you look at the landscape of quantum gravity approaches, then you will see 3, 4, or 20 or 50, depending exactly on how you define things. But the one that is not something I work on, well, all in a limited manner, but indirectly, but one of the approaches and ideas that have been put forward and are certainly very much studied and clearly exciting and convincing for a lot of people is the so-called gauge gravity duality, and which can be seen also independently from quantum gravity, but is certainly also one key idea for many people towards the theory of quantum gravity. And I know that you have done some philosophical analysis of gauge gravity dualities. And so what's your take from the philosophy side? What did you learn, or where were you confused about concerning gauge gravity duality?
Right. This is a lovely question again, but it is a very important topic. And in your series of interviews, I hope talk from what we said earlier privately about who else you may be speaking to. You'll talk to people much better placed than me about the detail. But it is true that in the last 5 to 8 years, philosophers of physics, they heard, of course, that dualities were a big thing in physics, and they began to think about them philosophically. And the most relevant one for quantum gravity is the so-called gauge gravity duality, which came into sharp focus in about 98. Especially associated with the Argentine genius Juan Maldacena, now working in the USA. And the fundamental picture is that there is ever so many detailed quantum theories, all sharing the framework of quantum theory, words like Hilbert space and physical quantities as operators. And this fits a space and time where there is no gravity very well. So it's called quantum field theory. And there's a particular group of them called conformal field theories. And they are well established over these last 80 years since the coming of quantum theory. And on the other hand, general relativity does describe gravitation. And Maldacena and his colleagues realized that there is a detailed correspondence between some conformal field theories, which are therefore on a space-time in which there is no gravity, and a theory of gravity. But the curious thing is that this correspondence is between a gravity theory that takes place in, as it might be, 3 + 1 = 4 dimensions, the normal dimensions of space-time as we have it, and the conformal field theory must live on something with 1 dimension less. So it is on the boundary. And the gravity theory lives in what is called, very English, vivid, everyday word, the bulk, meaning the volume. So people draw pictures of cylinders like a tin can of soup, and in the bulk or volume of the cylinder, there is gravity.
So,
Or the soup, right? When you think the soup, there is a space-time which is described by an explicitly gravity theory, and on the surface of the can, one dimension less, there is a conformal field theory. So this is very striking. It's very delicate and subject to highly mathematical assumptions to make it work. One is called supersymmetry, which I frankly don't understand at all, never really studied. But there are certain limited, highly mathematical assumptions in which it is in effect provable that the gravity theory in the bulk makes the same description as the theory on the boundary. And of course, philosophers, they are logic choppers, as we say in English. They like to make logical distinctions. So the natural philosophy question 5 or 8 years ago was, oh, are these really the same theory? We study logic, so we think of theories, as we were saying before, as axiom system, collection of sentences, derivations. What does it mean for two theories to be the same? Well, there's a logic tradition that studies that, both in terms of syntax and in terms of semantics, to use the words coming from linguistics. Syntactic approaches to theory, semantic approaches to theory. So it was natural when dualities came into the headlines from physics that philosophers would say, oh, hang on, are they really the same theory? So this is our topic, kind of.
So for a physicist, normally what we would mean is that for any quantity you would compute and then possibly measure within one theory, there will be some other uniquely corresponding quantity in the other theory that would give you exactly the same number when you go and compute it and possibly measure it. And the striking aspect is that if this is an exact correspondence and not just some approximate one, and something that holds for any quantity and not just some of them, it would somehow mean that, to say that in the world within your theory, there is gravity or there's no gravity, well, it may be exactly the same for all practical purposes, so to speak.
Yeah.
Picture the world that will not depend on that. You may have a picture without gravity at all and still be able to compute whatever you want to compute and measure. And similarly, if you thought that you were living in 3 dimensions or in 4 dimensions of space-time, well, fine, but you could as well have a complete picture of the world in 1 dimension more or in 1 dimension less, depending on which side of the duality you look at. And somehow this is, even from a physicist's point of view, it's a bit striking, because somehow it means that elements of our theories that we thought were crucial, in fact, can be traded for something different. I mean, the dimensionality of space and the presence or not of gravity and curvature and all of that. And but do you think it's an exact duality, or would you say that it's an approximate one?
Yes, well, of course, in some limited cases, it's a proven exact duality. And there's a whole cluster of good proofs that it is at least approximate. So whether nature really has an exact duality of that type, I'm agnostic. But I would also want to just endorse what you said, dear Daniele, that I spoke about the philosophy interest being, are they really the same theory? But you made it very vivid what is truly at stake, because it does, at the end of the day, the word theory can be defined more strictly or more liberally. And there is, under a very strict definition, typically 2 theories will not be classified as the same, because you define theory in a very strict way. Under a more liberal definition of what a theory is, you might well find that 2 things could end up being the same theory. Well, that's enlightening, but there's not a God-given way to use the word theory, very strict or more liberal. But what really matters is what you said, that the correspondence, if it's not approximate, involves that apparently all the observations we make can be understood in terms of the world has no gravity and we live in dimension, call it d, little d. Or it can be understood as a world with gravity and we live in a world of dimension d plus 1. And this is extraordinary. I mean, and it is worth saying, actually, in the light of your talking, we hope, to Robert Brandenberger in another session, that before gauge gravity duality, there were in this same area of physics, string theory, other dualities. And Brandenberger and Waffer wrote very deeply about something called T-duality, where, as I understand it, this is not about a bulk and a boundary at all. It's about, well, it's like the word roundabout that I had before. If there's a circle in the world, it has a radius. And they analyzed this idea that there could be, so to speak, a circle in the world of a radius r. And then the theory was such that you couldn't tell whether that radius was really r or 1 divided by r, which would be, for a large r, 1 divided by r is correspondingly very small. And so there's a duality under the operation of turning the radius of the roundabout into 1 over the radius. So anyway, I don't know much about T-duality, but Brandenberger wrote very...
Right. You brought up another example of the same type of general issue, which is that, let me rephrase it in a slightly different manner. We pretend that our theories, when they are successful, correct, empirically fine, and so on, just describe the world as it is. And all these dualities are somehow putting under some doubt all this naive picture, because when true and exact, that they say, yes, you could describe the world perfectly with a theory with such and such ingredients, including a certain picture of space-time, like the dimensionality or the fact that the dimension is large or small, and or a different one, and they are equivalent. So I would say that it forces us to question either the correspondence between our theories and the world, because clearly it's not one-to-one, in some subtle way, or our understanding of those ingredients in the theory as being fundamental, like space-time and dimensionality and gravity and so on. In both cases, is really, really striking. So which brings me to another, something that I wanted to ask in particular about this dualities. So normally when we physicists decide reluctantly to talk with philosophers, it's because we maintain that our theories allow us to find what the world really is and what are the real fundamental entities. And if you are in quantum field theory, you would say the world is made out of fields. And if you were in Newtonian mechanics, you would say, well, there are point particles and some forces, whatever. So to put it in I played the philosopher, so I use the word. We find out through our physics work what is the ontology of the world, and what truly exists. And it would seem to me that dualities would put under question this very fact.
Yes.
Would you? Is that where the reason why you're interested in dualities, and one aspect of the story that you're interested in?
It is certainly one aspect, and this is again, I'm grateful for the question, because there are two things to say, I think. One is, when we are confronted with this equivalence, theory one in my left hand, theory two on my right hand, they seem to entirely match everything about everything I could measure, and yet they're quite evidently describing the world in apparently contradictory terms. Dimension D or dimension D plus one. So in such a case, to avoid believing a contradiction, you have to say something like, reality admits each of these ways to be articulated. Reality is not itself contradictory, but it is possible for the human mind to capture all the physical phenomena with D dimensions and with D plus one. So reality admits apparently contradictory formulations. And in that context, there are really two more detailed options. Once you've agreed, you must avoid explicit contradiction. I think one option is to say, tomorrow we must try to formulate a theory which doesn't use dimension D or D plus one, and it just is so clever that this tomorrow's theory we hope to find, it will make the word dimension and the value of it, D versus D plus one, as a human choice about how to represent a reality. It would be a very highfalutin, sophisticated cousin of the choice between British feet and German meters, right? A human choice, which is obviously conventional, feet and meters.
I have opinions about that.
Oh yes, I'm sorry. I mean, I admit to the recording that I think Brexit was a big mistake, and but that's another discussion. So anyway, one can construe what seems our most deep and brilliant theories, of which we have the one on the left and the one on the right, with this apparent, they are deep and brilliant and highly sophisticated, and yet one might say this apparent contradiction must be resolved by regarding central concepts like dimension that seem indispensable to human thought as actually something like an arbitrary choice. And in fact, for physics people nowadays, they would say gauge, which is a buzzword for a human choice in which once you've made it, you can speak truly. Or fixing the gauge is like choosing to use feet or meters. So anyway, this is one way to go. But the other way to go is to say, well, no, there need not be some theory tomorrow which will make it clear how the existing concepts, which seem to have contrary formulations of D or D plus one, it is not necessary to do that. Reality is, to use the Greek word, amorphous. It has no structure. And we can articulate it with dimension D, we can articulate it with dimension D plus one, and we live with that. And we don't try to find an explicit representation of a single reality which exhibits left-hand theory D, right-hand theory D plus one as explicit choices of human. We just live with diversity. And the background philosophy is only expressible with the vague words. Reality is unstructured. It can be molded this way, it can be molded that, but do not look for a single vision that underpins the two ways to mold it.
So from this point of view, in this second choice, you would argue against the idea that there is a single ontology that we read out of our theories. You can work with different ontologies just as well as you work with different theoretical descriptions of reality. And while in the first case, somehow you think that there would be some fundamental ontology, which then you will be able to describe in two different but equivalent ways. Right? Is this...
Yes, I mean, I must admit, the trouble with the second position, I think it is intellectually coherent, but it is something you, by definition, cannot say very much about, because you have said reality admits these two apparently contradictory formulations. Do not try to say more.
Mm-hmm.
That is coherent, but it is not a position which will be scientifically fruitful, because you have decided that you need not or cannot say more.
Mm-hmm.
First position, which says tomorrow we will understand better how what seems objective in fact reflects a human choice. That objective and contradictory, and that's why we're worried. That first position is obviously a spur to more research. So, it's more scientifically hopeful.
I see.
But I think the second position is a bit pessimistic, but it is coherent. I should add, actually, that in all this dualities discussion, I am very beholden to Sebastian de Haro, who is a string theorist turned philosopher, with whom I've written about dualities, and he understands, of course, the technicalities much more. So everything I've said about dualities, I hope meshes with Sebastian's views. But anyway, this is how I feel about it. Yeah.
Yeah, very good. So let me raise another point, maybe the last, but related again to the gauge-gravity duality, but also related to what we were discussing earlier about quantum gravity. So let me pose the issue from this more general point of view, because it's something I also work on. So the idea that it's quite shared by all quantum gravity approaches, although phrased and tackled in different ways, that the very notion of space and space-time are in fact emergent. They are not fundamental. Somehow, whatever is the more fundamental theory, whatever is the more fundamental quantum gravity theory, will not feature space and time as fundamental notions there, and will recognize them as effective, emergent, approximate description of things that are valid even just at the conceptual level, only in some particular regime, as we were saying, or approximation. And the gauge gravity duality is, to some extent, is an example of that, although I think it's very different from other situations, because indeed, you were saying that there is a description in d-1 dimension, in d dimensions, and equivalently, you can describe things with d+1 dimension. So there is one extra dimension that you should be able to reconstruct out of the d-dimensional theory, even if it was not there to start with. So in this sense, it will be emergent. So you have done a lot of work on emergence in physics, but you, in particular, you tackled the issue whether there is a contradiction between the idea that some phenomenon is emergent and the idea that we can understand it on the basis of a more fundamental theory. And this second possibility, of course, is crucial for any quantum gravity understanding of space-time as emergent, because if that was not possible, then what will quantum gravity add to an emergent space-time?
Right. Yes. Well, thank you. I think it is true that I wrote saying, although reduction and emergence are normally considered that what each of them excludes the other, it is possible to have a case which is both reduction and emergence. And I agree that this is good news for quantum gravity, because roughly many programs in your science, quantum gravity, will want to say something about the familiar space, the familiar time of the quantum theory and general relativity is emergent. But we want to get a rigorous understanding of this. And this suggest to most physicists reduction, because reduction doesn't, well, I think in the wider culture, reduction may have a very strong negative connotation, namely that it destroys or denies or eliminates the attractive and complex and lived reality. So if somebody says, well, love is just the hormone levels in the brain, that's reductionist and it sounds depressing. And I don't think of reduction as eliminating what gets reduced. It gives you further information about something that is real and still is real after the description is given. So if in fact being in love or falling in love is associated with different biochemical levels, this in no way undercuts the reality of love or, the moral imperative about how to behave to your beloved. Right? It's just true that we are feeling that moral imperative and that love underpinned by certain biochemical levels. So reduction is not eliminative, okay? And in this way, I would hope that quantum gravity, such as a program such as your own, can achieve a reduction in a way that, of course, sustains the reality of the space and time as described by familiar physics. But it will also say that the familiar physics, space and time, is emergent. Yeah.
So it will add and enrich our understanding of the emergent phenomenon without removing what is nice about it. And
yeah. This would be my hope. Yeah.
Very good. I guess that's. I mean, with this call to love and to not spoil the strength of the love, I think we can stop here, right?
Yeah, I think yes. I mean, you have very generously led me down a very friendly path, with the torch in the basement and out in the fog,
carrying the torch,
and with the passion of love maintained. It's been an absolute pleasure, Daniele. Thank you so much.
Thank you, Jeremy. My pleasure.
Okay, so I hope we'll be in touch soon, and thank you again. Yeah.
Bye.
Okay, bye.